Alright then my friends, so now I'd like to talk about two more types, and they are arrays and object literals. So the first type I want to talk about are arrays. So what I'm going to do is create a new variable called names, and I want to give this the type of an array. Now when we give something a type of an array, we use square brackets, but also we have to specify what type of data is going to go inside the array. So for example, that could be strings, it could be numbers, booleans, etc. So if I want to have an array of strings, I would type that by saying string and then square brackets, meaning a string array. And now this can only ever be an array with string values inside it. We can't put numbers inside it or booleans or anything like that, just strings. But that's okay because normally when we have an array of something, it is an array of data, which are all kind of like the same type. So it might be names like this, which are strings, or it could be an array of scores, which would be numbers, or user objects, or blog objects, or something else. They would typically always be, though, the same type as each other. So now this is defined as a string array, and I could put some values inside this. So I could say something like Mario, and then Luigi, and oops, it needs to be in a string, Luigi, and then Peach. But I couldn't add something like a number. If I do that, then I'm going to get an error under this, and that says the type number is not assignable to type string because we're saying all of these must be strings. Alright, cool. So let's do a few more examples. So I'm going to come down here and create a new variable, this time called ages, and the type of this is going to be a number array. So to do that, we say number, then square brackets. And we can set this equal to an array with some numbers inside it. So I could say something like 25, 28, 24, but if I tried to add some other type like a boolean, then it's not going to let me. We get an error because this must be an array of numbers then. Alright. So we've defined those different arrays and we've given them some different values initially. And what I'd like to do is now try pushing new values onto these arrays. So I could take the names one, for example, and use the push method to push a new item onto the array. Now, if I try to do something that's not a string, I'm going to get an error because we've said this must be a string array. But if I try to push a string, like Bowser, then everything is hunky-dory. Alright, let's do the same for the ages. I could say ages.push. And again, if I try to add something that's not a number, for example, a string, like string version of 35, I'm going to get an error. And the error says argument of type string is not assignable to parameter of type number because this must be a number array. Well, let's change this to a number, so 35, and everything is fine. Awesome. So that's how we define these different array types using square brackets. And then in front of those square brackets, the type of data inside them. Now, TypeScript can also infer the values inside arrays as well. Much like if we had a variable like my name and set it equal to a string, which was Mario, and it will infer the type to be a string, it can infer the type inside arrays as well. So let me get rid of that and instead say let fruits equal to an array. And inside here, we'll say something like apples, pears, and bananas. Oops, can I spell it? Bananas. And then we'll do one more. Mangoes. Alright, so now if we hover over this fruit variable right here, you're going to see the inferred type. It's a string array. So it's looked at the values inside this array and said, okay, it's a string array because it's full of strings. Therefore, I will infer that type to be a string array. And now, if I try to say something like fruits.push, and then, I don't know, true, which is not a string, then we're going to get an error because it must be a string. However, I could push on another string, for example, peaches, and this would be fine. Alright. Okay, so let me do one more example here. I'm going to say const f, that stands for a single fruit, is equal to the fruit array, and I'm going to grab one of the items, so we'll say index 3, which is this one right here, mangoes. Now also TypeScript is going to infer the type of f for us as well. And it knows that it's a string because it knows that this is a string array. So no matter what item we get from this array, it knows it's going to be a string. So if I hover over f, we can see it infers that type of string for us, which is awesome. Alright, so let me do another example. Actually, I'm going to say let things equal to, and then add array. And we're going to put some different types in here. One, and then true, and then hello. Alright, so we're not explicitly giving this a type, and therefore we can put different types of dates inside it. Now, when we hover over this, you're going to see let things is any of these types right here. Now we're going to look at these different types later on where it can be one of a number of different types. This is called a union type. However, know that now if we try to get something from this, if I say, for example, const t for a singular thing and set that equal to things, and then 0, if I hover over t, then you can see, look, it's going to be one of these three things, but it doesn't know exactly what t is because it doesn't know exactly which one we're grabbing. Yes, we're saying 0, but the order things might change in the future. 0 might not always be a number or a string or whatever it is currently. So TypeScript basically says, look, it can be one of these types, string, number, or Boolean. Okay then, so now let's move on to objects. How do we type object literals that have specific properties or a kind of specific structure? For example, we might want a variable to be an object, right, that has a name property or a first name property, an age property, and an ID property. But how do we kind of annotate that as a type? Well, it's kind of long-winded, but you basically write out the entire structure of the object itself as a type. So for example, I could make a variable called user, and I want that to have that very specific object structure that I just mentioned with a first name, an age, and an ID. So what I would do is add a colon to specify the type, and then the type is going to be an object, so curly braces first of all. Then inside the curly braces, we say what properties this object must have, and then also the types that the property values must be. So for example, we'd have a property of first name, and the type of that must be a string, right? We'd also have a property of age, and the type of that would be a number. And then finally, we'd have an ID property, which should have a type of number as well. So right here, we're saying that the type of this user variable must be an object, which has these three properties, and those three properties must have these types assigned to those properties. Now, it doesn't matter what the value of those properties are. They can be anything. Remember, we're just specifying the types here, and the only thing set in stone is the structure of this object, including the types of these properties. So let's give this a value then. So let's set this equal to an object, and we're going to have a first name property, which must be a string. So we'll say Mario, that's fine. Now currently, look at this, we're getting an error, and it's saying that this type right here, this object that we've currently made right here, and we're assigning to this variable, it doesn't match this type. Well, obviously it doesn't yet because we've not finished, but that's what this error is for. It's saying that this right here is missing the following properties from type, and then this type that we created. And those properties are age and ID, so we're currently missing those two properties. So let's add those on. We'll say the age is going to be 30, and we'll give an ID, which is going to be 1. And when I do that, that error goes away because now this object, this value that we've given to this variable, matches the type of that variable, okay? So that's absolutely fine. But watch this, if I try to add on another property like is fictional and set that to be true, then we're going to get an error right here, and that error says that basically this is not defined inside this type, so we're not allowed to use it as the value. So, well, let's get rid of it, and we'll just stay with that. Alright, so what if we try to change some of the values on the fly of this object? Let's try that. Let's go down here and say user.name, and let's try setting it equal to a different type, so it must be a string. So I'm going to say 25, and yeah, we get an error. So he says property name. Oh, it should be first name, not name, first name. And we still get an error, and that error now says type number is not assignable to type string because this must be a string. Let's change it to a string instead. So I'm going to say peach, for example, instead. Alright. So what if we try to add on another property? So I could say something like user.email this time is equal to peach@netninja.dev. And it's not going to let us do that because this email property right here does not exist on this type that we declared up here. So we can't just add on new properties. We've got to stick to the structure after we typed it. So we can't do that. Let's get rid of that. Let's try changing the ID. So let's say user.id and set it equal to 2 as a string. Yep, not allowed because it must be a number, but we can change it to another number. That's absolutely fine. Alright, cool. So now let's move on to type inference with object literals. So much like other types, TypeScript can infer the type of a value when we give it a value of an object literal. So let me give a quick example. I'm going to say let person equal to an object, and we're not giving this a type. So we'll say the name is going to be Luigi, like so, and we will say the score is going to be 35. So now if we hover over person, we can see that it's inferred the type, which is this object with a name and a score, and there must be a string and a number. So it's looked at the properties and values here, and it's created the type for us. Essentially, it's inferred that type. So now if I come down here and try to say person.name is equal to true, a boolean, which is a different type, I can't do that because it's not the same type as this, but I can change it to a different value, which is of the same type. For example, Bowser, that would be fine. I could also change the score. I could say person.score and set it equal to another number. However, if I try to do a different type, it's not going to let me do that. And then if I try to add on, for example, a different property, so I could say person.id that doesn't exist and set it equal to 3, it's not going to let me do that because that was not specified initially. It's not part of this type right here, so it's not going to let me do it. Alright, so one quick example here. If we try to get one of the properties, I could say const score is equal to person.score, and it's going to infer the type of score for me inside this variable. So I could hover over here and it says score is a number. It knows that because it inferred this type right here. And whenever we get the score property, it knows it's going to be a number. Alright, so that's the basics of arrays and object literals. Next up, we're going to move on to functions. Okay then, so now I want to talk about functions in TypeScript, and we're going to focus on two different parts of a function. First of all, the arguments in a function, and then also the return value of a function, right? So I've got a function here already set up which takes in two arguments, a and b, and it returns the sum of those arguments. And so far this looks identical to a function in regular JavaScript, except we get these little errors right here where the arguments are, and that's because we're not telling TypeScript what types these arguments should be. Now in regular JavaScript, we can invoke this function and pass in any types of data as arguments, and it wouldn't cause any errors or bugs until runtime, right? So I could pass in a string and a boolean into this function, and we find out if there were any errors or bugs with that. When we come to run the code, it's not going to tell us beforehand, but in TypeScript, we need to specify the types of arguments we want this function to accept. And then when we invoke that function, it won't let us pass in the wrong types. And that's going to result in less runtime errors and bugs because we've already fixed the problem ahead of time. So then, let's give these arguments a type. So we'll say that A must be a number and B must also be a number. And we can also explicitly tell TypeScript what type of value this function must return by adding a colon after the parentheses and then adding the type itself. In this case, I want the function to return a number. So I'll write a number, and that means if I try to return a different type of value now from the function, then it won't let me, and I'm going to see an error telling me that this is the wrong return type. Alright. Okay, cool. Alright, so now let's make another function, but this time I'm going to create the function as an arrow function just to show you both types. We've got a regular function right here. Now we'll do an arrow function. So to do that, we can say const, give the function a name. We'll say subtract two numbers. We set that equal to a function this time, and we're going to take in two arguments. Again, we'll call them a and b, but they can be whatever you want, and they're both going to be numbers. So we'll say the type of a is a number, and then the type of b is also a number. This is going to return a number. So again, colon after the parentheses, then number, and then because this is an arrow function, we use the arrow and then open up the curly braces. So we're pretty much writing a function in the same way. It's just that this is an arrow function and this isn't. Alright, now currently, notice this error. And it says right here a function whose declared type is neither undefined, void, or any must return a value. So basically we're saying here we want to return number, but we're not actually returning anything yet. So let's return, and then it's going to be this time a minus b. And now the error goes away because we are returning a number. Alright, so let's try invoking these functions. I'm going to say add two numbers. Like so, I'm going to pass in two numbers, so 3 and 9 for example. And this works, we don't get any errors now. But if we try to pass in something that's not a number, for example a string 9, then this is not going to work. And if I try to pass in something different here like a boolean, this isn't going to work either. Now the error is going to wait here, and that's just because it's reading this first. But if we get rid of this error by changing it back to a number, then it moves on to the next error it finds. And it says this one is a string. It should be a number. So let's change this back to a number and everything works. Okay, the next one, subtract two numbers again. If we invoke them, then I can pass in two numbers and that works fine. However, if I change one of these to a string, it's not going to work. Awesome. So that's really helpful. Hopefully you can see the benefit of typing these out, because then when we come to invoke these functions at a later point in time, it's going to minimize the errors we make by making sure we pass through the correct types of data that that function expects. Alright, so let me do another example. I'm going to create another function, this time called add all numbers. And inside this function we'll accept an argument called items, which will be a number array, so number then square brackets. Now this function is going to look at this items array, and it's going to take all the numbers inside it, add them all up to a total, and log that total to the console. Now we're not specifying a return type right here, and I'll explain why shortly. For now, I want to paste in a line of code which grabs us that total. So we take the items, which is an array, and we use this array method reduce, which we can do by the way. Let me just grab this right here. We can use array methods because this is an array. TypeScript knows this is an array, so it gives us access to all of the different array methods and properties right here. If we try to use something that wasn't an array method, then it would give us an error, but this is an array method, so we can use it. So we use that reduce method, which finds a function for each element inside this array, and it basically adds them all up with a starting position of 0, and it returns that total right here. Okay? So we have that total value. Now what I'd like to do is log that to the console. So console.log, and then we will say total. Okay. Now, the reason I've not specified a type right here to return is because we're not returning anything. So if I come down here and say add all numbers, and then pass in an array of numbers, so I will say 5, 7, 9, 11, 3, 2, 1, then the return type of this, if you take a look, is void. We don't get return. And this void type means nothing is going to be returned from this function. Now we can't explicitly type that right here, void, and that's going to do the same thing for us, except this time it's not inferred. Where we didn't have this, it infers the return type, but when we explicitly type it, then it's explicit. Now if we were to return the total, then this is not going to be valid because now this is not void, this is actually a number. So we would have to specify a number right here to say the return type is a number, but again, if we don't specify that return type, TypeScript is going to infer it looking at the type of this. So if we hover over this function, we can see it's inferred the type of number as a return type. Okay, I'm going to go back to void and not return anything. Alright then, so now this all works. Let's try previewing this in a terminal because we do log it out. So hopefully you've still got those watch commands running in the terminal. I'm just going to open this because I have, and we can see the node one has restarted this file, and we can see this output right here, 38, which is the total, I think, for these numbers. Awesome. Okay, so there's one more thing I quickly want to mention in this video, and we have already touched upon it, and that is return a type inference. So I'm going to paste in a function right here, and this function is called format greeting, and it takes in two arguments. A name, which is a string, and also a greeting, which is a string. Now inside here we return basically a template string which combines these two, so it takes the greeting first and then the name. So this could be good morning, and this could be Mario, and it could be good morning Mario that we return, which is a string, right? Now we're not actually explicitly saying what the return value is right here, but TypeScript is going to infer it for us. So I could say const result is equal to format greeting, like so. I'm going to pass in the two arguments, so the name, which is Mario, and I'll just say hello right here for the greeting. And now if I hover over results, it's going to say that this result is of type string. So it inferred what value type is being returned right here. And it knows what value type is being returned because this is a string. And it knows it's a string because we're explicitly returning a template string, right? We're not returning a variable that it doesn't know. We're saying it is a template string right here. So this is the same. It's just putting up here. String infers that type, but a lot of the time, we don't need to put that up here. So that's pretty much it for functions. Hopefully now you can see the benefit of typing these arguments. And also, by the way, just when it comes to inferred types, if we don't explicitly say the type right here, so if I don't say string right here, then basically I can return any type over here. So if I wanted to here, I could say return 10, and it's going to let me. However, this function really shouldn't be returning a number probably. So it sometimes is beneficial to say what the return type should be if you want to enforce that down here, because now you see we get an error because we're not returning a string. All right, go. So like I said, there's functions in action. In the next video, we're going to look at another type called the any type.